Okay, guys, polars, and Justin, you wanted polars. It's just a different way of graphing, and you have to remember how these are graphed, and have to know how to graph points. It's r comma theta. So if I have 2 comma pi over 2, I will find my angle. We always measure off of the x-axis. Okay, so we're always going to measure this way, and I'm going to rotate 90 degrees, and then I'm going to plot the point 2 units from the origin. But what if I have negative 2 pi over 2? You have to realize this. Not so much because you're going to be plotting points, but if they give you the picture of the polar function, you have to figure out the angles what everything the rays are rotating through. So if I have this one, I'm going to rotate 90 degrees, and I'm going to go negative 2 from the origin. Let me change colors at least. So that would be this point down here. And probably the best way to illustrate that would be to actually do one of those free response questions. So what if I rotated 0 degrees and the radius is 0? Where am I going to be? At the origin. So I know on one of them it was rotating, what was it, pi, and then it was negative 1. So you're going to go 180 degrees, but you're going to go 1 to this direction. It's very tricky.
Why is that tricky?
Because you have to remember that's what's happening. It's tricky because you have to remember what's happening. It's just a different way of thinking. Oh, we will do problems. First, I'm going to review everything you have to know about polars.
Quickly, though.
Oh, yeah. I'm not going to spend a lot of time. So you go pi radians, and then you're at the origin, but you're going to go 1 the other direction because it's negative. Well, it's 1 pi. So the rotation's 180 degrees. We start from the origin. We go 1 unit this way. Okay. So these are the essential pieces, Matt, that you need to know. Okay, you guys. If this is the radius, this is the point x, y. If I drop the altitude here, this length is x, and this is my angle theta. So you need to know this relationship. What's the cosine of theta? It's the adjacent leg over the hypotenuse, which is x over r. So x equals r cosine theta. What if I want the y value? The sine of theta is equal to y over r. So y is equal to r sine theta. And since I can't get to my tools, I will do it this way. Maybe. Okay, so you need to know this. You also need to know that x squared plus y squared is equal to r squared, so that's pretty obvious, right? Right? And what's my angle? If x equals r cosine theta, y equals r sine theta, if I ratio that r sine theta, r cosine theta, which is equal to what? Y over x, that is the tangent of my angle. So you might have to find that angle. So x is equal to, or theta is equal to, sorry, inverse tangent of y over x. Now, it's rare that r is going to be a constant. R is going to be some function of theta. So if they ask you for the derivative of x with respect to theta, then I would take the derivative with respect to theta of r times cosine theta. Nice time to review the product rule. So that's going to be r times the derivative of cosine. You can memorize this, or I just work it out every time. Negative sine of theta times the derivative of the inside part, which is d theta. Just so you know what's happening. We always have the chain rule. Plus, and then we have cosine of theta times the derivative of r, dr d theta. So it's not something simple when they ask for dx d theta, but it's easy if you know this. And you can do the same thing for dy d theta, correct? What I usually do is I don't do this. I actually substitute in what r is, and either I multiply it out, actually we'll put it in right here, multiply it out or use the product rule there. But whatever, it doesn't matter, as long as you realize that's what's happening. And do you remember how to find the slope of the tangent line? It's just like vectors. dy d theta over dx d theta. So you have to know that as well. Yeah, it's not bad. And do you remember the area formula for a polar region?
L equals
The area is equal to, not the length,
integral.
1/2 the integral of r squared d theta, from theta 1 to theta 2. Now, did I get it?
Is there a reason it's 1/2? Just curious why there is.
Yeah, let's go ahead. It takes 2 seconds to do this. This is the area of a sector. This is theta. Now, how do you know, you guys, this is nice to know because in case you forget on the exam. R squared d theta. What is that? What's the area of this sector? It's theta over what? 360 times pi r squared. We're always supposed to be in radians. Okay, Justin, how many radians in 360 degrees? Oops. 2?
Hold on. Pi.
So this is theta over 2 pi times pi r squared, and you see where the 1/2 comes from. Okay, so this is 1/2 r squared times, guys, Justin. Okay, I don't believe this is harassment. If we can't be quiet, I'll walk out the door. Okay, you need to get through, we need to get through this.
You walk out the door, man, it's like crazy.
No, nothing will happen, and oh well. Okay, you guys, this is important to realize. It's not r that's changing. When you add up these little pieces, it's the angle that's changing, right? So that's why this is d theta. So it's just that little bitty angle, and you're going to add up all these little sectors. So there's just little delta thetas. I can't think of anything else at the moment. That doesn't mean there's nothing, that I'm not forgetting something. So let's go ahead and do a problem. Okay, so we have to know how to graph this. What is r equal to 2 equal to?
What is the blue one?
Well, first thing you gotta have a circle.
What's the blue one? You only have 3?
I have no idea.
You only have 3 multiple choice brackets?
You have 4. You should have the, and they're all should be over there. You should have 1997, 1998, 2003, 2008. Okay. So we're gonna draw this. Ooh, is it crooked?
The gold one is 90.
And if you've done the problem, then work on something else. Okay, girls, use your time. I know. Do a different one.
But I did all the multiple choice ones already.
There's other problems to do. There's lots of other problems.
Where?
You've done all the free response I've given
I
you?
said I did all the multiple choice.
Yeah, work on a free response.
Has anybody
Any of them?
all these things?
Yes.
Actually, for
Every single problem?
I have. I'll be honest. I
Stop. No, you
I
haven't.
finished
Okay, this is
literally almost every single packet that we get.
1998.
You got a 5.
Okay, you guys,
I'm trying to do the intercept, but I can't get it.
we're not going to do that
Why?
because it's not a calculated problem, so you have to know what this looks like. What's r equal to 2 look like?
Circle with radius of 2 at the origin.
Remember the calculated problems. The calculated problems start at 76. Now, remember there were 3 things I asked you to know how to do. One of them was just r equal to a constant. This one, r equals 4 sine theta. The other one is r equals 4, similar to this, before cosine theta, r cosine theta. If you don't know what to do, let's plot some points. If theta is 0, what's the sine of 0?
How many multiple choice questions are there?
I don't know.
It's 0.
Okay, Justin, I'm going to have you sit over there because you're not paying any attention, and you're the one that requested this.
Okay.
Okay. Because the next place, it's out the door. Okay, what about pi over 2? What's the radius? What's r? What's the cosine of sine of pi over 2? 1. So this is 4.
Yep.
So this is 2, so I'm going to go up to 4. Does anybody know what this is?
It's a circle.
What if we do pi? So I'm going to rotate pi, and I'm not going to move from the origin, so I'm back here. So I'm going to undo that. And so this is a circle. Oh, let me just do this.
Do you really have to draw it out?
I can't do without doing it.
So on multiple choice pies, you would draw it out. I think that would be
Oh, yeah.
Really? What's that?
Yeah. So this is 0, right?
Um,
So if you're talking about r equals 4 sine theta, this is on the y-axis, a circle of radius, not 4, but r equals 2. And this is going to be on the x-axis. Those are the 3 graphs you have to know if it's multiple choice.
Only those 3.
Remember, I don't get to see every multiple choice problem. So to the best of my knowledge, r equal to a constant.
so cosine is on the x-axis.
Right. And remember, x equals r cosine theta. That was the x-coordinates. That's how I remember it.
What do you mean by on the x-axis?
Okay.
It's a circle. If you wanted to graph for cosine theta, it's going to be a circle over here. And that's going to be at 4.
That's 4 cosine.
Yes, because you can just plot some points and figure out where it is. You know there's circles. They're not going to give anything worse than that. If they do, they'll give you a picture. If it's non-calculator. If it's calculator, not so much. It multiplies whatever the value of cosine theta is. So if theta is equal to 0, r is equal to 4. That means I'm 4 units from the origin. It's not a radius.
When you say, I know, when you say that, we have to know those 3. Could it be like 6 sine angles?
Right.
We have to set the code.
Right, you have to know this. R equals some number times the cosine of
It'll be
theta.
that same circle, except it'll be
It'll be bigger.
diameter of 6, but it'll still be with the left at the origin.
Yes,
Okay.
they're always the same. Okay, and it says the area of the region inside the 4 sine theta, that's this one, r equals 4 sine theta, and outside the polar curve r equals 2, which is the other one. So they're asking for, oh, I don't want that, this region right in here.
I know James Bowling's good, pretty good.
Okay, you guys, how are you going to do that?
Like Jason.
Well, let's figure out what we're going to do. We're going to look at this and look at this, and I need to find those intersection points. And no, I don't believe in polar graphing that you can find intersection points. I know you can't in parametric graphing, you have to actually trace. Pardon? Well, how do you find the area? It's 1/2 r squared d theta. Well, how do you find the area trapped between those 2 regions? It's the big circle minus the little circle from these intersection points. So it's going to be what? 4 sine theta squared. Don't make the classic mistake.
There's an arrow here that gets you if you don't know that.
Yeah, but it's just like washers. You don't do r minus little r squared. You have to do r squared minus the other r, which will do d theta. And then we have to integrate from this angle. Well, that's where these are equal. So you have to know a little trick, and you probably can make a good guess based on the answers. I don't have the answers in front of me. This is equal to what, 2? So the sine of theta is equal to 2/4, or 1/2. So what's theta? Pi over 6. And you can see by the symmetry, this is pi over 6. And I'm counting how many 30-degree angles there are. Do you remember this little trick? It's 1, 2, 3, 4, 5. Yes, I wish I'd known that many years ago. And now let's see if we have a match. Do we have a match? So first I'm going to do my angles. Obviously it's not these guys.
There's the trick.
Not that one.
It's a trap.
See, it's a trap.
There's the trap.
It's a trap. Trying to suck you in, Mr. G.
Okay, so we're on one choice. It's this one minus that one, and there it is, D. So it wasn't that bad.
Wait,
But every concept will be tested.
how?
You only have 2 minutes on that question.
I'm teaching it. I'm not doing it.
Basically.
Pardon? You have to either memorize that or you can make a table of values and you can see that's a circle.
Because one part G is not specific.
Okay, shh. So I can hear questions.
That's 4.
What's for?
Have to square outside.
Don't use the word that or it. You gotta give me some ideas. Yes, because this was 2.
Wait, so it only go from 0 to pi, really? Because that's how long it takes to make a full circle.
Right. And so if you go to 0 to 2 pi, you're gonna go around the circle twice. Okay, let's try the next one.
Messy. Look at this. Look at this guy.
I have to do, yes?
I think it's impossible to use.
Yes, we'll have to do, oh, I gave those to you. Yes, I did. I gave you a handout on all the polls for Form Bs.
Oh.
Because I know you didn't have those.
Pull the marker.
Then I did that.
Handout. It's in chapter 6 under the word files. It's tan colored. It's in chapter 6. We did a lot of stuff in class, yes. So I'm going to put this in here. This is going to clear that out. 3 theta plus the sine of theta.
Great.
Did they give us the domain? 0 to 2 pi. So, window, 0, 2 pi. And I don't honestly know, well, I do know how big this possibly could be.
Before.
Well, let's just graph it, see what we get. A little slow.
So you could just integrate it from.
Well, I don't know. I'm going to take the picture.
Like this.
Which I can make a little bigger, but I don't care because it just says the first quadrant.
They all look different as G.
So the second.
What do you mean they look different?
Mine looks different than Kevin's, which looks different than
Probably
yours.
have a different window.
Check your window.
What's your window size?
0 to 2 pi.
The angle is there. We're stepping slow. That's the problem. but y min is negative 10, x max, x min is negative 10, well, x max is 10. So it's just a standard window.
You just integrate from 0 to pi over 2, right?
I did 2 pi.
Well, I mean, from the...
I don't know what else it's asking me in the problem.
How do
So
you do this mode again?
you press mode,
Oh,
and
the
it's
second.
colors. No, I think it's just, I don't know. It says find the area in the second quadrant. This is what I'm talking about when I say you have to know how to plot points, because you have to figure out what the angles are.
Yeah, but it's just like the second.
Yes, but you, not necessarily. Okay, so enclosed by the coordinate axis in the graph of R. So it's this distance right here. So I have to figure out where that is. Where do you think that is?
You suck.
Well,
His calculator doesn't graph it right. It's the same exact as mine.
are you in radian mode?
Oh my
Okay, so we know we have 1/2, right? R squared. This is so easy here. 3 theta plus the sine of theta squared d theta, and now I need my angles. And if you just look at this, you could solve for it. When is this going to be 0? Not the theta is going to be 0 here. What's theta here? Does it work? So r, I'm going to check. R pi over 2, which is 1.57, is 3 times pi over 2 plus the sine of pi over 2, which is 1. So that's 9/2, 4.5, that's 5.5. 1, 2, 3, 4, 5.5. Looks like that'd be right. So it's pi over 2, and where do you think that is? Pi? I don't think I have the answers here either. So let's check that out. What if it's pi? If theta is pi, then r of pi is 3 pi. How big is 3 pi? Plus the sine of pi. So that's 9. That looks like, because remember my window was 10. So I'm going to guess that that's probably right. And unfortunately, I didn't bring up the answers. I could.
If you just found the area in the first quadrant, would you get 1 point or would you get nothing?
You probably get nothing. So read the problem twice.
So we have,
No, you'll actually, because what you'll do is you'll get a point for this. That'll be 1 point, and then you'll get a point for this. So if you did the wrong corner, if you had the wrong angles, I looked at my picture, and I said, let's just try pi over 2. See, because I don't really know what that point is,
why'd you pick that over two?
because it's a 90-degree angle. And what about 0? What's r of 0?
Just use trace, get it?
Probably.
0.
So 3 times 0 plus the sine of 0. So it's starting here, it's going to go over here, and pi over 2 is going to add on a 1. It was just guess and check.
On the exam, do you have to do it that way, or can you just go with trace?
You can do a trace, does that work?
Isn't it easy?
But,
Like,
Where's my calculator? I think I lost it.
but they could give you this 9 calculator, right? Some polar stuff.
They will give you the picture if it's something like this.
And they might ask, set it up, but don't solve it. They won't.
Well, they might have you solve it. Well, no, they'd probably set up. Yes.
why do you have to, if it says,
As long as you know that that's where it is. I have to double check to make sure I'm right. Now, you could look at your graph, and we could do a trace, because there is no, if you go second calculate, there is no 0. Yeah, you can do that. Second pi, second pi, clear. Second, where's pi?
Oh, yeah.
Where's, I can't see it. Oh, okay. Sorry, second pi, I see that now barely. Divided by 2, yeah, you could do that. And sure enough, I can check it that way. Because you're allowed a graphing calculator. Or you could just trace. You know, you can see where that is. So could you have used decimals on this? Because it's a graphing calculator problem? Yes. I'm at 0.01. It's going to take me forever to get there. I want to be at 0.1 if I want to do that. Okay, let's look at the next part. Between pi over 2 and pi, there's 1 point on the curve with x-coordinate -3. Find the angle that corresponds to point B. So I have a point on here. And it says the x coordinate was what? -3. So it's going to be somewhere there. So x equals -3. And it says find the angle. How do I find the angle? Theta is equal to what? Inverse tangent of y over x. I have to find what y is. What's y equal to? Actually, I don't need to do this. I did this the first time.
If you do x equals r plus 1.
Yeah, I was just going to say, because when I started to do this, y equals r, sine theta. And I know that I need the angle there. So x is -3 is equal to r, what's r? 3 theta plus the sine of theta, that's my r, times the cosine of theta. Can you find theta? I would go to a regular window personally on this one and actually solve this one graphically. 3x plus the sine of x, cosine of x. That's all they're asking for. Did they ask for the y coordinate? Find the angle. That's all. Find the y coordinate then. So then what are you going to do? You're going to find y of whatever this x value is.
That's pretty complete.
So we can do that if you'd like.
No thanks.
Do you know how to do that and actually not have to type in all those decimal points?
What do you mean?
That's not going to be a nice number.
Then what would you find? How would you find the angle?
Why
That
would
would give
you
you the
want
x
it? Why,
value.
That's x and the angle are the same. Whatever this number is whatever that number is.
Wouldn't you go back to
Yeah, it's all radius. I'm just going to go back into this mode to look for that graph. Because that's what I want to do. What?
Wouldn't you just go back to y equals r sine theta, sine theta, theta?
Right, so you're going to have r of theta, whatever this is, times the sine of theta. In this case, these are x's. Maybe we should do this.
So Ms. Jewish,
Now, I probably can do it in polar mode, but I've never done it in polar mode, so I'll go back to regular mode and just do it. Well, we're going to find x, so we're going to solve that. I got to get my calculator. And I'm going to change my mode. Actually, see, 'cause I can't find intersection on here. That's the problem. So I'm going to go back to mode, change it back to function. Can't find zeros either.
Pi over 2.
Okay. Now I'm going to go to y equals and clear all that stuff out. And on this one, I either can find zeros or I can just -3. And then I can type in 3 at, whoops, I forgot my parentheses.
can you store that?
Well, you can store it, you don't have to because it's whatever, as left and x is going to work. And sine of x, so you can just use x, but if you're worried about losing it, then yes, I would store it. And
Wait,
then
you
that's
just
the
said
cosine of
you
x, right?
Store that?
Yeah, we'll do it. Let me find it first. Have you found it?
Yeah.
Then I'm going to zoom trig.
No!
Honestly.
What is you doing?
Mitzi, you should yell at your next
I
one.
mean, this happens every day.
This class ends at 12:05, doesn't it?
7.
Someone comes out.
12
Okay.
7.
We want between 0 and, you guys, we want between pi over 2. I'm going to change my window.
1.5 seconds.
This is going to be pi over 2, second pi divided by 2, and then this is going to be pi, second pi. Because I don't want to look at all that other stuff, right? Right. I only want this intersection point. Hopefully there's only one. There may be a second one, but I don't know for sure. Notice that this tells me we're thinking. Yeah, if I changed it to 0.1, it would have been. You can change your resolution. If you look through those tips, it'll talk about how to change your calculator so graphs faster. That's the resolution on the window. Okay, I want to do second. Calculate. I want it, that intersection point. It's probably faster on an Inspire. 2.016, right? Now, I want y, which is r of theta times the sine of theta. Where is r of theta? Well, I don't have it there, do I?
So your theta is 2.01
Yes.
radians.
So I'm going to go back to y equals, and I'm going to put in y3. I'm going to put in y2. No, I'm not. I'm going to type it. 3x, I didn't want to do that. I could have been more efficient, but that's okay. Sine of x, you guys, we're not done, times the cosine, sine of theta, right? Now, all I have to do is find that y value. So all I have to do is go to my main screen, pick up y3, and I've got the new software, new system here, so I can do that easily. y3, enter, and do this of x. I didn't have to store it.
Whoa. Oh.
That saves me a ton. But on the exam, you would have to write all those decimals.
Right.
And there's my y value.
Can we see the answers?
Yeah, I'll have to bring them up.